Mastra just released observable memory. Future Harry here. Apparently, it's called observational memory, not observable memory. So wherever you hear observable memory in the video, please switch it with observational memory. Thank you. A human-inspired approach to solving how agents can remember things long term. I've tried building agents that require long-term reasoning or long-term memory, but the more you use it, the worse it performs. All right, so let's even assume you attach RAG to your system. All it does is introduce complexity and latency, and sometimes it's not usually the best solution. With observable memory, it eliminates all of that complexity because they found a way to use text compactly instead of vectors for long-term reasoning. So how does observable memory work? It's quite simple actually. Let's use a scenario. Let's say you're talking to someone, right? You're having a conversation, and 2 weeks later, you don't remember exactly how it went, word for word, but you remember facts. That's because your brain subconsciously reflects, reorganizes, and compacts all of the key information into facts that is then stored in your long-term memory. So here's the problem. As your conversation keeps growing, you tend to use more tokens, right? And your cost increases because you're using more tokens. As well as that, information that you might have discussed here or here might not be included in the last token usage because it's been so far behind in your history, right? Which makes your context unstable. However, with Mastra, how it works is this. Your context window is divided into two sections, your conversation history and your observations. And there are actually three layers that make this work. The observer agent, the reflector, and your entire history, entire observation panel. Right, so this is how it works. As conversation grows, um, once it reaches a particular threshold, the observer keeps on monitoring your conversations. Once it reaches a threshold, it will compress all of your conversations into observations and store them inside of the observations panel. Right, as this also increases, right, and it reaches the observational memory threshold, this part of the system, which acts similar to how our brain retains memory longer, sort of reflects on the information, reorganizes them based on our preferences, and then compresses them into more useful facts. Now, you might be wondering why are all of this color coded? So this is how Mastra was able to attach importance to each fact. Red means very important, yellow means medium importance per se, and then green means low importance. The observer also keeps track of the current task and the suggested response so that an agent, the overall agent which uses this memory system, knows where it left off. So for example, we can go into the doc. They talk about an agent that's using Playwright MCP. Playwright should be a tool that allows an agent to use a browser, right? So it sees about 50,000 plus tokens per page, and then it doesn't really need to carry all of the snapshots all the time. The observable memory tells it what the current task is and what the suggested responses are, and then it can just carry on from there. So it knows the important things. Um, what they said was that with observable memory, the observer watches the interaction and creates a few hundred tokens of observations about what was on the page and what action we're taking. Right? The agent stays on task without carrying every raw snapshot. Let's actually talk about the comparisons with RAG and observational memory. With RAG, it usually involves some sort of external retrieval with some other database, and we have to do vector searches with embeddings, and those searches are based on a query. With observational memory, it usually involves some internal evolving memory, and then it's text compression based. It's not vector based. You don't need to make any vector embeddings. It's basically based on the text, and then the search is done based on the context as well. So it's quite compact and it's quite simple. It's not as complicated as all of this. I think these agents will shine the most with personalized experiences. So if you're trying to build a system which will give your users a more personalized experience, I think this is where it will shine. From the top of my mind, I can think about maybe a customer support agent and a personalized learning tutor agent of some sort. So it's to have like a mind map of all of the strengths of the student, and you can use that information to better the experience or the learning experience for the person using the the agent, I guess. This solution might not be for everyone, but if you're trying to reduce token usage, build long-term workflows, or build tools that will offer a more personalized solution to your users, maybe try observational memory out and see how it suits your use case. If you're working with agents or you're starting to learn how to use agents, memory is very important. And the observational memory seems like one of the cleanest solutions out there to tackle long-term reasoning issues. If you want to see me break this down or implement this with Mastra and TypeScript, let me know in the comment section. If you reached all the way here, thank you so much for watching, and I will see you in the next one. Peace.